And this is our last probability video. We're going to look at two more complicated examples. So for number 5, we have that 2 dice are rolled and we want to get the sample space for this event. So I'm going to go ahead and kind of X out some of this stuff in the middle so you can sort of see what's going on. That's just extra space. But we're going to list what we get for each die. So let's start with the first die. We know that when we roll a die, our possibilities for answers are 1, 2, 3, 4, 5, or 6. So I'm going to take under die 1, and I'm just going to go through and I'm going to list all of my possibilities so I can get 1 through 6. Okay, so now I want you to take that 1 and I want you to bring it all the way down. And let's do the same thing with the 2. All right, and we'll do this all the way down. This is a good way to start this because this is a complicated sample space. All right, so let's roll our 2 die. Let's say I roll the first die and I get a 1, so I know I'm right here. My second die can still be anything. I haven't rolled it yet. So when I roll it, I can get a 1, a 2, a 3, a 4, a 5, or a 6. All right, so each of these pairs represents an outcome. So for example, if I took 1, 3, right, that would be this line right here. That represents rolling a 1 for the first die and a 3 for the second die, and that's considered to be one outcome. So if let me erase that. If I just continue this, if I got a 2 for the first die, I could still get for the second one 1 through 6. Okay, so I'm just going to go all the way down my table filling that out. All right, so if I count these, remember a pair is considered to be one outcome. There are 6 outcomes kind of on each set, so that would be 6, that would be 6. All the way across, I would get 36 possible outcomes. Now this is really important because when I do probability, I'm going to put that number in my denominator. So for part A, we want the probability that the sum is 2. So the only way that's going to happen is if I get a 1 and a 1. So I'm looking at this set right here. All right, so that's going to end up being, oops, not very good at switching back and forth. There's 1 outcome out of 36. Now, if I think about a sum of 7, there's a little bit more options here. So on the first column, I've got 1 and 6. 2 and 5 makes 7. 3 and 4. 4 and 3. 5 and 2. 6 and 1. And if you want, you can write those down. So 1 and 6, 2 and 5, 3 and 4, 4 and 3, 5 and 2, 6 and 1. So that's a total of 6 favorable outcomes out of 36 altogether. And then if you want, you can reduce that to 1/6. All right, so now let's think about a sum of 9. I'm going to switch highlighters here, switch colors. If I look at my first column, I can't get a sum of 9. My biggest sum is 7. The first time I can get a sum of 9 would be right here. So 3 and 6 make 9. If I go to the next column, 4 and 5. The next column, 5 and 4. And the next column, 6 and 3. So I'm going to write those down. I could get 3 and 6. I could get 4 and 5. I could get 5 and 4, and I can get 6 and 3. So notice you get the flips, right? You get the 3 and the 6 along with the 6 and the 3. So that would be 4 outcomes out of 36, which would reduce to 1/9. And you don't have to reduce, but you can. All right, so how about a sum of 15? Well, I know the biggest sum I can get is 6 plus 6, which is 12. So this is actually impossible. So if you get something impossible, that would be 0 outcomes out of 36 which is just equal to 0. So a probability of 0 is an impossible event. Okay, let's add one more. We're going to work off some of the things we already did. Let's say I want a sum of 7 or 9. Well, I can take my answer from part B. Let me switch colors here. Part B was a sum of 7, and I know that that had 6 outcomes. And then for 9, I can look over here. I know that that one had 4 outcomes. So in this case, I can go ahead and put those together and put it over 36. So there's 10 ways to get either a 7 or a 9 out of 36. You can leave this here, or you can reduce it to 5 over 18, whichever you want. I don't really care if you reduce or not. All right, so our last one deals with a deck of playing cards. Now, you may or may not be familiar with cards. I'm going to flip over to a deck of cards real quick. All right, so this is a standard deck of cards, no jokers. So there are 52 cards total. Okay, there are 4 suits. Okay, so we have spades and clubs, which are black. We have hearts and diamonds, which are red. And there are 13 cards per suit. Okay, and then you'll notice that each suit, it goes from ace to king. All right, so if you need to refer back to this, I'm not going to write up the sample space because it takes too long. Basically, this is a sample space. But you can refer back to this part of the video if you need to look at a deck of cards. And I'll try to attach a copy of this as well. All right, so if I think about a red card, okay, so I know there's 52 cards altogether, so I'm thinking about out of 52. So if I look at my red cards, I can see there's 13 hearts and there's 13 diamonds. So that would be a total of 26 red cards. Or another way to think of it, if you reduce this, it's pretty clear from the picture that half the cards are red. So the fact that it reduces to 1/2 is not a coincidence. All right, so now let's think about a king. So if I go over here, I can see I have 1, 2, 3, 4 kings. So that would be 4 out of 52. And that reduces to 1 out of 13, which makes sense because you have 1 king for each suit, and there's 13 cards in a suit. All right, now we want a black face card. So a jack, a queen, or a king, but we do need it to be from a black card. So here's 3 right here, and here's 3 down here. All right, so that would be a total of 6 black face cards. So that would be 6 out of 52. You can reduce it if you want, but you don't have to. This one comes out, I believe, 3 out of 26 if you reduce. Either one's fine. And then the last one is the ace of spades. Well, there's only one ace of spades, right? Right here. There it is. So that probability is just going to be 1 out of 52.